Hi everyone, welcome to the class guys. Please confirm once that am I audible to you or not, everyone. Sorry. All those centers who are connected, please confirm that am I audible to you or not. Okay. So guys, in the last class we were discussing about the nitric acid. That in few cases nitric acid won't produce the H2. It actually converts the H2 into the H2O. Okay. That we have discussed in the last class. Now we have to continue after that. Now, the next is your aquaresia. Okay. Excuse me. Okay, so aquaresia, what is the meaning of the aquaresia? First of all, that aquaresia is not a substance, it is a mixture actually, okay, which contains HNO3 and HCl, okay. Now, why do we use the aquaresia and where and how we can prepare it, okay. So, to prepare the aquaresia, we need 3 parts of the HCl and 1 part of the nitric acid. Means, if you are taking the 3 moles of HCl, then you need to take the 1 mole of the HNO3 to prepare the aquaresia. Okay. So aquaresia is basically being used to dissolve the inert metal. Inert metal means which do not react with anything, or we can say any other substance. Okay. That is what we know. That is what we call inert metals, or we can say the inert elements. Okay. For example, gold and platinum. We know that gold is actually the inert, okay, or we can say if it reacts with air. Why I'm using the air? See, the first of all, the important point that why do we generally use the jewelry of the gold? Just because it is not reactive, okay, and we know that if gold reacts with the air, it slowly becomes little bit we can say dark, not dark exactly. Its shines actually goes away slowly. So what we do actually, we dissolve, or we cannot dissolve, actually we use a chemical just to cleaning of those jewelry, okay, which is being prepared of the gold, or the we can say the platinum. Now platinum is also in the trend that we are having the jewelry of the platinum as well, okay. So actually what I was actually trying to convey, that gold is basically used in the jewelry purposes just because it is not reactive, okay. Now the question is, in this world, nothing is permanent, okay. So similarly there is something which should react with gold as well, okay. There are lots of things can possible, but if we talk about the chemical terms, the solution, okay, the solution which reacts, or we can say which is able to dissolve the gold or platinum is what? Aquaresia. Okay. So what you have to do? Simply put that gold or platinum in the aquaresia and it will simply dissolve it. Okay. Just because that mixture has a very strong oxidizing nature. Okay. So here you can check out that gold does not react with hydrochloric acid or the nitric acid. Okay. However, gold dissolves in a mixture prepared by mixing concentrated HCl and concentrated HNO3 in the ratio of 3:1. 3:1 means 3 parts, or we can say 3 moles of HCl and 1 mole of the HNO3. Okay. This mixture is called the aquaresia. Okay. Aquaresia has some sense in the Latin. It means it is royal water. Okay. It is one of the very few reagents that is able to dissolve gold and platinum. Okay, then aquaresia was discovered around 1300 AD, means it is very old, okay, by European alchemist Pseudo Geber, when he mixed common salt with vitriol, sulfuric acid. In the Middle Ages, it was one of the ways that alchemists tried to find the philosopher's stone, a legendary substance allegedly capable of turning inexpensive metal into the gold. Okay, that you must have heard about it. Aquaresia is presently used in wall mill process. This process is used for the refining of highest quality of gold. Okay. So what is important part in this one, that you should learn that aquaresia is a mixture of hydrochloric acid and the HNO3, and it is used to dissolve gold and platinum. Okay. I hope so it is clear to everyone, all those who are connected. Please copy it and then confirm. Copy and then confirm. Please copy and then confirm. Done. So let's move on. Okay, so this is an interesting fact. So this is interesting, so we can see what is interesting in it. Not only this, aquaresia is also has a very interesting role interesting role to play in history. Okay, when Germany invaded Denmark in the World War II, the Hungarian chemist Georgy the Hevesy took the Nobel Prize medal of two scientists, Max von Leon and James Frank. To keep them safe, he dissolved the medals, which were made of gold, into aquaresia. He did this so the Nazis would not steal them. He then placed the jar that held in the solution of aquaresia and gold on the shelf in his laboratory at Niels Bohr's Institute. The jar looked exactly the same as hundreds of other jars in the laboratory. The Nazis thought that all the jars had normal chemicals in them. After the war, Havesi returned to the lab and found the jar with solution and removed the gold from it. He returned the gold to the Royal Swedish Academy of Science, and the Nobel Foundation later on used the gold to make new medal for the Leo and the Frank. Were really interesting. Hey, hi Itanago, welcome. So guys, see, really interesting. Okay, seriously, this is really interesting that how they have saved that gold medal. They dissolve that into the aquaresia. Okay, and later on, he given it back, and then they got their gold medal again. So really interesting. Hey, hi, Tamalong, welcome. Good evening, by the way. Okay, so let's move on, guys. Now the question is for you: which metal will react fast with acids? Now this question is to you guys. This question is for you guys. Look at the question and tell me the answer. Tamalong, Itanago. Oh wow, Itanagar is too quick with his answer. What do you think, Tamalong? Okay, so let's check out the answer. Oh wow, there is no answer such that, but yes, with the help of the these test tubes you can predict. See, in the test tube of the calcium, you can see the bubbles. That bubbles are showing that when you put the calcium into that acid, it is very reactive. Only just because of that, it is forming the fumes over there, bubbles over there. And rest are reacting little bit slowly. Even copper is not reacting over there. Zinc is reactive, then magnesium is also reactive. Okay, so higher is the fumes can tell you that which one was more reactive. Okay, I hope so it is clear to everyone. So it is nothing but the observation. Look at the 4 test tubes very carefully and check out. I hope so everyone has seen the dispersin. When you put the dispersin into the water, it reacts very fast. It gets dissolved into it within the seconds actually. Okay, dispersin tablet which is being used for the headache. Okay, so it is just like that. So answer would be the calcium, absolutely right. Reactivity series, what is it and why do we use it? See, reactivity series tells us that with respect to the other element, which one is more reactive. Okay. So the reactivity series is a series of metals in order of the reactivity from highest to the lowest. Okay, means potassium having the highest reactivity, whereas platinum is the least reactive. Okay. It is used to determine the products of the single displacement reaction, whereby a metal A will replace metal B in the solution if A is higher in the series. Okay, we will use it, guys, in the displacement reactions. Okay, so first of all, just look at the series and you should remember these elements. Okay, I'll suggest please do remember these elements. Okay, that potassium is the highest, has the highest reactivity than sodium, calcium, magnesium, and on moving down the table, we will get the platinum. Okay, so platinum is actually the least reactive. Dear, I'll just tell you that, see, not only these elements are available to us in the reactivity series, there are many more, but these are the important ones. So, right now I don't have any such method to remember them. I'll suggest please do practice in a notebook, okay, to remember this. Okay, So first of all, please copy it and then confirm. And if you have any question, you can ask me. Copy and then confirm. Copy and then confirm. First of all, we'll discuss about the metals now. Then we'll shift to the non-metals. Okay? Have you copied it, Anago? First of all, we will continue. We'll finish up this one. Okay. So, reaction of metals with other metal salts. Okay. So, metal C, salt of solution A, salt of solution C plus metal A. Means this is a general reaction. Okay. Now, this is the displacement reaction. This is just to show that how a metal can displace the other metal. See, as metal C displaces metal A, okay, because it is being combined with the B to form the BC from the solution, it means that C is more reactive than A. Okay. See, in the compound AB, if other metal is replacing that element, it means that that single atom, that single element was much more reactive as you compared with the other element. Okay? That's what this means. So please copy this one, and if it is not clear to you, just let me know one thing. Or please just let me know. Yes, it needs a salt solution where we can displace the other elements. Okay, for that we need the salts. Please copy it and then confirm. No, they will react in the solid state. Sorry, aqueous state, not solid state, aqueous state. Solid is the most stable state, so it won't react. Okay, and as these are the metals, so they are not in the gaseous state. Okay, in the solid state, they are in very highly stable state. That's why they won't react. Metals are not in the gaseous state, so that is not possibility. So we are left with the aqueous. So this is aqueous solutions. Please copy and then confirm. Itanagar, have you copied that? Okay, so let's move on. So this is the chemical reaction, guys. Okay. Reaction of iron nails with copper sulfate solution. Ultimately, these are showing the displacement reaction, nothing else. Okay. So as copper sulfate is blue color solution, while FeSO4 is green color solution. One second. So you can copy these few important reactions actually. Important displacement reaction. Need not to draw that stuff. Okay. Please copy this one. Copy and then confirm. These are the important displacement reaction. Yes. There is metal-metal displacement reaction. Copy and then confirm. And yes, please mark your attendance as well. Okay. This is the question for you guys. Tell me, what should be the correct answer for this one? Tamelong, Itanagar, tell me answer for this question. How many days you need to solve this question? Tamelong, Itanagar, are you there? Okay. You said B. What is written over there? It is react with the acid to evolve the hydrogen. What do you think? Will it happen when non-metal is reacted with acid? Similar reaction will take place. Reaction might take place depending on the non-metal, but no hydrogen gas will ever be evolved. Okay. So let's move on. This is the reactivity series that we have already copied. Okay. So that's all about this slide. Let's move on to the next part. Okay guys, so we have completed that. Now there is a recall test. Okay, you have 5 questions. Please mark these answers quickly as soon as possible, and after that just inform me so that we'll check out the solution part. Please do this. Come along, have you done the answers? I mean, have you solved the questions? Okay. See. And tell me how many correct answers you have got. Okay. What was the question number 2? Okay, Mn reacts with dilute HNO3. Yes, this is false. Not. Okay, to evolve H2, na? Yes, it is correct. Okay. Now, formation of cations and anions in metals and the non-metals. Okay. So guys, this is the concept actually. Okay. Guys, look at this. I'm taking an example, just look at the screen. We know that atom is electrically neutral. So this is the concept actually. First of all, understand this concept. See, I said there is an atom which contains 2 electrons and 2 protons. Okay. Electron means negative charge, and proton means positive charge. Okay. So if I talk you about the electrons, you will say what? -2 charge. If you say proton, you will say +2 charge. If I ask you the total charge, What will you say? Charge on electron plus charge on proton. Just add them. -2 plus 2 equal to what? 0. This is what actual atom look like. Now, I am saying from this atom where 2 electrons and 2 protons were there, remove 1 electron. Okay, so what will happen? Remove 1 electron, so what will happen? From -2, -1 charge has been removed. Now total electrons left will be what? -1. But protons, in protons there is no change. So what will happen? You will get the +2 charge. I say now add them. On adding them you will say what? It is +1. So actually what happened? When you remove an electron, there is an imbalance of number of protons and electrons, and that imbalance in the number of electrons and protons develops a charge. Here you can see +1 charge. +1. It means that +1 is nothing but the charge. Let's suppose this is atom A. So what actually I am trying to say, when atom A loses 1 electron, it will develop +1 charge. Okay? Now, consider the same scenario. 2 electrons, 2 protons. I am saying introduce 1 electron into it. So what will happen? We will have now 3 electrons, but protons, no change. So I'll say what? -3 charge and +2 charge. Add them. On adding them, this is nothing but -2 plus 2. Sorry, -3 plus 2. This is nothing but what? -1. So what happened? Suppose this is atom A. Atom A is gaining an electron. So it will develop what? -1 charge. Okay. So actually what do we have concluded? That first of all, the formation of charge is just because of in the imbalance of electrons and the protons. First thing. Second thing, whenever an element loses the electron, it will develop the positive charge, and if element gains 1 electron, it will develop what? Negative charge. Other than that, this positive and negative charge, see this one, whenever there is a formation of a negative charge, we called it as an anion. Okay. Whereas if there is a formation of positive charge, it means it is known as what? Cation. So actually these ions can be of two types, cations and the anions. So cation will be will be formed when there is positive charge, and anion will be formed when there is a negative charge. So this is the whole concept. First of all, tell me, are you clear with the concept? Everyone please confirm me once. Everyone please confirm me once that is it clear to everyone? Okay. Now, we know that when a positive charge is being placed nearby the negative charge, just because they are having the opposite type of charges, there is nothing but a force of attraction. That force of attraction is nothing but what? Ionic bond. Ionic bond is nothing but it is the force of attraction between the cation and the anion. Okay. So I hope so it is clear to everyone. Now if it is clear to everyone, you can copy this one. Okay. Please copy and then confirm. I hope so now everyone is able to explain why atom develops the positive and the negative charge. Please copy and then confirm. See, copy this one as well. I have discussed about it. And guys, if you are having any doubt, you can please ask me. So then in the, when in nature are they usually found in their usual form or on the ionic form? See, NaCl, which is a salt, sorry. See, NaCl is a salt, which is in the ionic form, okay. NaCl which you generally use in your home, okay, the tablespoon, the table salt, okay. So it can found in the nature, in the ionic form. No, atoms can't find in the ionic form, na? Ionic bond will always be available in a compound. Oxygen is element. Sorry, if you are saying zero element, yes, no element can be in the ionic form. So this is the ionic bond formation. See, I have told you about it. Please copy this first. And if you would like to ask me anything, please. Please copy this one and then confirm. If you are having a doubt, you can please ask me. Copied. Properties of ionic compounds. Ionic compounds are also called the electrovalent compounds, as they are formed when the valence, or which is the outermost electrons of one atom transfer to another atom. Means the important point here is ionic compounds are always formed by the transfer of electrons. Okay, transfer of valence electron. Valence means the electrons which are present in the outermost shell or the orbit. Okay. Now, if we talk about the general properties, ionic compounds are solid and hard because of strong force of attraction between the positive and the negative ions. They have high melting and boiling points. This is because a considerable amount of energy is required to break the stronger inter-ionic bonds, or we can say inter-ionic attraction. Okay. So this is the important property of this one. Okay. First of all, copy this one. Copy and then confirm. See guys, if you are having any doubt or question, you can please ask me. Okay. Whatever important term is there, I have discussed with you. Okay. That why ionic bonds are formed. Okay. And between which type of elements it can exist. So please copy and then confirm. No, both are exactly different things. Is electrostatic force of attraction act between the two magnets? No, na? That is a magnetic force actually. But between the ionic bond, or we can say between the elements which are ionic, there is an electrostatic force of attraction. In the magnet, it is a magnetic force. No, we can't see that bond. We can't see that bond, but yes, I can tell you. One second. I can tell you one thing. or you can represent it like this. This is Na plus, this is Cl minus. So you can represent that force like this. Okay. But this is the imaginary picture just to make understand. Okay. You can't see that bond. No. They are at some distances. They can't touch each other. Okay. They won't touch each other. Please copy this one. These properties as well. These compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, because these are non-polar. Okay. Ionic compounds in the solid state do not conduct electricity because movement of ion in the solid state is not possible. Okay. But ionic compounds conduct electricity in the molten state or the aqueous state. Okay, Itanago. Please copy. Okay, please copy this one as well. Copy and then confirm. Polar means a compound which have some charges, positive or negative. Polar is in reference with the charge. Means if a molecule, if the elements which is in a compound are having some charge, okay, that charge actually makes them polar. Means that is what we call a polar substance, having some net dipole moment. About that you will study in the higher classes in detail. Copy and then confirm. Copied. Itanagar Tamilong, have you copied that? Okay. Question for you guys. Attempt this question. Okay. Itanagar is given the answer. Tamilong, what do you think? Okay. Okay, so answer is B. Very good. Okay, so guys, next topic is corrosion. But before starting of that topic, let's take a quick break of 5 minutes. Okay. I'll see you in the 5 minutes, guys. Okay. Be there. Hi guys, welcome back. Please confirm once that am I audible to you or not. Itanagar Tamil long. Okay, cool. Okay guys, so next topic is the corrosion. Okay. So first of all, tell me what do you understand by the corrosion? If someone asks you that define corrosion or say something about the corrosion, what do you say? What corrosion is? I hope so you have heard about this word. Okay, degrading of metal surface. Yeah, cool. Quite good answer. Okay. So this is the corrosion, means where a metal get attacked by the air, or we can say the moisture, or it comes in contact with the acid, it gets start degrading over there. Okay, the degradation is nothing but what corrosion is known as what corrosion. Okay, so even you know the rusting of the iron. Rusting is the example of what corrosion. Okay, where the iron get rust over there and it start degrading over there and destroyed in, we can say, after some time. Okay, so that is the example of corrosion. So here we can define corrosion as corrosion is a natural process which converts refined metal to more chemically stable forms such as oxide, sulfide and hydroxide. Okay, more stable as in that after the getting attacked, it converts into the different product depending on the situation, whether it will form the oxide, sulfide or the hydroxide. The surface of the metal get corroded when they are exposed to the air, moist air for the long period of time. Okay, so this is the general phenomena that you have observed in your daily life as well. Okay, now when the acidic substance comes contact with the metal such as iron, rust begins to form. Okay, so this is what the corrosion is. First of all, copy these points, and if you are having doubt among these 3 points, you can ask me, but please copy this one and after that confirm me. Please copy and then confirm. Acid is not corrosive. Acid actually causes the corrosion. Corrosive means something which can get corroded by some other substance. So acid is actually that substance which helps in the corrosion, means due to which corrosion takes place. No, it doesn't applicable to the non-metals. It's generally applicable to the metals. Have you ever seen diamond is get corroded? That is non-metal. It do not corrode. No, it can't convert back to its initial form. If substance get corroded, it means you can't get the pure metal after that because it has converted into the oxide. Okay. And after getting into the oxide, or we can not only the oxide, okay, there might be some other possibilities as well. If you would like to obtain that metal, then you have to go to the refinery processes again. Okay, you have to go to the refinery processes again, and after that you can get. Okay, and even that the amount would be reduced over there. No, it is not possible in case of the diamond. I hope so, Itanagar Tamalong, you are clear with the doubts. Okay. Copied this one. See, in case of rusting of iron, iron reacts with the oxygen present in the air and the moisture and develop rust. Rust is nothing but hydrated iron 3 oxide. Okay. This is the chemical formula of the rust. Okay. So what you have to do, you have to write down that point and then this chemical equation as well. Please copy and then confirm. These are the images, nothing else. Okay. Need not to draw these images. Please copy and then confirm. Have you copied that? Okay. This is nothing but the corrosion on the copper. Okay. Actually, that greenish layer observed of the copper, that is actually calcium hydroxide, is nothing but the rust. In case of rusting of copper, metallic copper reacts with oxygen, carbon dioxide and atmospheric moisture and develop a green colored coating of copper hydroxide and copper carbonate. I hope so. If you have seen we can say the container, there are some containers as well that we use in the households, or we can say in some restaurants as well. So there is a greenish layer over there. Whenever it comes in contact with the moisture, okay, that greenish layer over the copper metal, or we can say the containers of the copper, is nothing but the copper hydroxide and the copper carbonate, okay, and that is the form of the rust in case of the copper, okay. So please copy this one as well, copy and then confirm. Copied? Okay. Now, prevention from the copper. There are many common methods, okay, out of which painting is also one of the methods, and but before painting there is a galvanization. So it is a method of protecting its steel and iron from rusting by coating with thin layer of the zinc. Means actually what happened that we coated the steel and iron with the help of the zinc, and zinc is actually non-reactive. I can say that zinc initially reacts with the moisture to form the zinc oxide, but that zinc oxide layer is passive in nature, means further that layer of zinc oxide do not react with the moisture, and further decay or the corrosion is not possible. It stops over there where once zinc get converted into the zinc oxide. Okay, so this is the advantage of the zinc. Okay, that's why we use it in the galvanization process. Painting, I'm sure that you know about it, that the surface is exposed to air is painted. Since paint contains oil, it forms thin passive layer on the metal and prevent it from the rusting. Okay, I hope so you're clear with the 2 points. If any point which is not clear to you, just ask me that. Please ask me and copy this one, copy and then confirm. No, if you're talking about the zinc oxide won't react, but other metal oxides can react. Zinc oxide is passive in nature. See, oxides can be of many types. Okay, if you talk about the zinc oxide, it is not reactive actually towards the moisture. Oil is actually not reactive, means it is not affected by the water not moisture. One second, guys. See, Al2O3 is not effective in the corrosion process over there. And second thing, yes, aluminum is too expensive as well. See, in the galvanization, we need the metal, or we can say the element, whose coating is actually effective over there. Effective as in, 1 minute, guys. I'm discussing it, Itanagar. Wait a minute. Okay, so let's get back to it, get back to it again. Your question is for the aluminium, na? The point is, first of all, to convert into the conversion of the Al2O3. Okay, see, directly aluminium won't get react with the moisture to get converted into the Al2O3. Okay, Al2O3 is get convert whenever you need to convert into the Al2O3, you need a high temperature. Okay, first of all, that is not possible to achieve in the normal process. Second thing, if you are saying that in anyhow I would like to use the aluminium layer over there, first of all, the layer whose coating you are making over there, remember that coating should be stick as in that the coating should be very effective over there, so that it won't remove easily. Okay, so remember one thing, that whenever you talk about the aluminium on reaction with the air, it won't convert into the Al2O3, which is passive in nature. Okay, it will directly get corroded over there, it will get destroyed. Okay, now you are saying, what about the aluminium foil? What about the aluminium foil? See, aluminium foil is a little bit different as in, yes, we use the aluminium over there, okay, that used to prevent the air, okay, that used to prevent the air, or we can say the little bit of moisture as well, to keep the food safe and hygienic over there. Okay, yes, it resists the air and the moisture, but up to some extent over there. Okay, I hope so it is clear to you. If you are still having some doubt, you can please ask me. And then point number 3, alloying. Means conversion into the alloy. Means it is a mixture of the two metals. Okay. So is it? No, that is not alloy. That is aluminium. Not even the pure aluminium. Okay. Not even the pure aluminium. Okay. And you want it is alloy as well. Alloy is something different. Okay. It is like the aluminium along with some other substances. I don't know the exact composition for that. Okay. I need to check it. Alloying is nothing but the homogeneous mixture of two or more metals and non-metals to change the property of the pure metal to protect them from the rust. Okay. Then electroplating. Electroplating is nothing but so then do we call it as a compound? No, you won't call it as a compound. Compound is something in which there is some specific composition of the elements. Okay. Electroplating. Electroplating is nothing but the plating of some other element which is non-corrosive in nature, to protect the other metal. Okay, it is a process of coating a protective layer of metal on another metal by means of the electrolysis. This prevents the corrosion. Okay, first of all, copy these 2 points, then we will discuss next. Copy and then confirm. See, I was checking the composition of the aluminium foil. In the aluminium foil, it is about 98% of the aluminium, pure aluminium. Okay, and rest other elements are present over there. Cheap as in what? Yes, kind of, quite cheap. No. See, you are saying then can we remold that foil into the vessel and sell it for the highest cost? See, the point is, you can do that, but the point is, will that really be the vessel? Means how will you provide the strength in that? The question is, how will you provide the strength to convert, to make that a vessel? That's the question. Okay? If you are talented, you can do that, definitely. Okay? There are some common alloys, guys, that you need to remember, quite important for the examinations. Like brass is an alloy of copper and zinc, bronze is copper and tin, solder is lead and tin, nichrome is nickel and chromium, steel is iron and carbon. Okay. So guys, this is very important to us. Please copy this one. Please copy and then confirm. Copied. Okay, copy then confirm.